Okay, so yesterday we talked about arc length for functions. Okay, the arc length of a piece of a curve over an interval. Today we are adding parametrically defined curves to that. Okay, so this is the formula from yesterday. This is from, oh, not far enough. This is the formula from yesterday. If we have a function that is x determined as a function of y, then it would be this. I don't think you're going to run into any of those, definitely not on a test or something like that, but you would have your x prime in terms of y here, and then it would be in terms of dy, okay? This is what we are looking at today, which is for parametrically defined curves. All right, if you did not already watch the video about parametric curves, then you still need to do that. Parametric stuff is going to come up in more detail in a later unit, so you need to understand what parametrically defined curves are and what they do, okay? But for today, this is our formula for arc length. It's found the same way using Pythagorean theorem and factoring out, in this case, it would be a dt. And I'm going to give you another notation here. So dx over dt is the same thing as x prime of t. So this is the integral from a to b of root x prime of t, and then that quantity is squared, plus, and then dy over dt is y prime of t, and then we are squaring that, and then dt. Move that over a little bit. dt. Yes. So for arc length, for a parametrically defined curve, we need the x and y functions, and they'll both be in terms of the parameter, which is usually t, sometimes theta. Okay, questions so far? Right. So, like I did yesterday, I strongly urge you to write your derivative expressions first before trying to plug things into the formula, because it is very easy to forget to square the derivatives, or to square the functions, forget the derivatives, okay, or both. So we're going to write what x prime of t and y prime of t are first, okay? So if x is root 5 sine t minus 2, what is x prime? Root 5 cosine t. What about the negative 2? Derivative is 0, okay? And then y prime is equal to what? Negative root 5 sine t. Everybody agree there? Okay. And we are integrating over the interval from 0 to 4, so plugging things into our formula now, we're going to square those on the inside. So we have the integral from 0 to pi over 4 of the square root of, and then what is root 5 cosine t squared? Plus, somebody else, what's negative root 5 sine t squared? You guys agree with that? Positive, right? Mm-hmm. Negative squared is positive. Don't let that be the reason that you can't evaluate this because you mess up your squaring of a negative number. Okay. You guys agree with that? Did you follow what he did? We can factor out of 5. It stays under the radical, but we can factor out of 5. Okay? And then we're left with cosine squared plus sine squared, which is a Pythagorean identity. That is equal to 1, so we just have root 5 times 1 dt. No. They weren't yesterday. Okay. Somebody else, what's the antiderivative of root 5 dt? Okay, evaluated from 0 to pi over 4 is what? Yep. Okay. Questions?